Okay, this is lesson 13 about using partial fractions to solve integrals. We use partial fraction to decompose the integral in two parts, or in three parts, or four parts. But each part is an easy problem to solve. It's an integral that is more easy to solve. All the integrals that we will see to use partial fractions are integral where the numerator have a degree. The degree of the polynomial that in the numerator is smaller than the degree of the polynomial in the denominator. So we are going to use partial fractions for integrals that consist in the division of two polynomials. One polynomial divided by another polynomial, where the polynomial in the numerator is a degree smaller than the polynomial in the denominator. If the polynomial in the numerator is bigger than the polynomial, the degree of the polynomial in the numerator is bigger than in the denominator, we make division, long division, and we solve the problems using long division. We convert the problem into two integrals that are more easy to solve. So let's go to solve all this problem using partial fraction. So partial fraction is being used like this. Suppose that we have to find the integral of 1 divided by x squared minus 9. In principle, I don't know too well who will be the antiderivative of this function. Very difficult to know, but the methods say decompose 1 divided by x squared minus 9 in two parts that are more easy to find. How we will do? Well, x squared minus 9 is x minus 3 multiplied by x plus 3. In principle, you cannot split the denominator. You cannot. But partial fractions say, look for a number a that when divided by x minus 3 and b divided by x plus 3 will be this one. Fix a and b in a way that when I sum this with this, will be this. So instead of solving the integral of 1 divided by x squared minus 9, I will solve these two integrals, but first I have to find a and b. So now, is possible to do it? Yes, it's possible. You know that the common denominator, if you make the sum here, it will be a multiplied by x plus 3 plus b multiplied by x minus 3 divided by x minus 3 multiplied by x plus 3. Now we have in the right side of the equation a denominator that is the same that denominator in the left side of the equation. So the numerator has to be equal to the numerator. So 1 should be a plus x plus 3 plus b plus x minus 3. Now we are clever using x. Who is x? Who we will use as x to obtain a and b? Well, I will use x minus 3. And minus 3 plus 3 will be 0, so this equation will read 1 equals 0 by a, which is 0. And here, because I have used minus 3 here because I have used minus 3 will be minus 6. So if I use x equal minus 3, the equation will read 1 equal a by 0. A by 0 plus b by minus 6. So a by 0 is 0. So b by minus c equal 1 means that b equal minus 1/6. To solve for a, I would choose x equal 3 because 3 minus 3 is equal 0. So if I choose x equal 3 to erase b, 3 plus 3 will be 6. So 6 by a will be 1. So a will be 1/6. So what we have done? We have convert 1 divided by x minus 3 multiplied by x plus 3 into two different terms that the sum, in this case the difference, because v is minus 1/6, is this. So instead of solving the integral here, we will solve two simple integral, more easy integral. So let's go to do it. So this is just done. The integral of 1 divided by x squared minus 9 is minus 1/6 minus 1/6 multiplied by the integral of x plus 3 plus the integral 1/6 by the integral of 1x minus 3 ddx. But this integral is the natural log of x plus 3, and this integral is the natural log of x minus 3, or if you prefer, 1/6 that multiply the natural log of x minus 3 divided by x plus 3 plus c. And the problem is solved. So the method of using partial fractions to solve the integral is to decompose one thing in two things, one function into the sum of two functions whose sum will be the original function. And this is the method. Now there are rules to do it. Not always you have to use, this is linear factor, x plus 3, x squared plus 9, x squared minus 9 is x minus 3 plus x plus 3. And these are linear factor. With linear factor, this works like this. When we find x squared plus 9, will be a different story to use partial fraction. Okay, let's go to try another. The second problem will be like this. Evaluate the integral 5 divided by x squared plus 3x minus 4. Wow, who will do this integral? Difficult, but we use partial fraction. To use partial fraction, we need first to factor the polynomial. Not always you can factor a polynomial. Indeed, it's difficult to factor a polynomial. Indeed, if the polynomial is of 4 degrees, you don't know how to factor the polynomial. But this polynomial is easy to factor. It's x plus 4 multiplied by x minus 1. The sum 4 minus 1, which is 3, is here, and the product 4 multiplied by minus 1, which is minus 4, is here, and you use quadratic equation to find that x equal minus 4 and x equal 1 are the solution of this equation. So the factorization of this polynomial is x plus 4 multiplied by x minus 1, and of course you can multiply the distributive property and you will find the left side of the equation. So 5 divided by x squared plus 3x minus 4 is 5 divided by x plus 4 multiplied by x minus 1. And now you can use partial fraction. Partial fractions say that these can be converted into the sum of two functions. A divided by the first linear term, x plus 4, plus v divided by the second linear term, x minus 1. And we need to find a and v. Wow! So the denominator here, if you make this operation here, it will be a by x minus 1 plus v by x plus 4 divided by x plus 4 multiplied by x minus 1. Now, because they have the same denominator here than here, 5 should be equal to the numerator here. So the 5 is ax minus 1 plus vx plus 4. The numerator equal to the numerator because the denominator are the same. So now I choose intelligent numbers to find a and b. I will choose x equal 1 and x equal minus 4. If I choose x equal 1, I will obtain b equal 1. If I choose x equal minus 4, I will obtain a equal minus 1. So finally, the integral that they are asking me is decomposed into two integrals. The first integral is easy to solve, the second integral easy to solve. And the problem is almost done. So now you know what is the integral of minus 1 divided by x plus 4, and here is the result. And we can go now to the next question. The next question say evaluate the integral 4x squared plus 2x minus 1 divided by x cubed plus x squared. Now x cubed plus x squared I can factor in like x squared that multiply x plus 1. So now the partial fraction that we will use is a divided by x. Now because x is a linear factor that repeats 2 times, will be b divided by x squared. So we make these things, this integrand equal a divided by x plus b divided by x squared plus c divided by x plus 1. And the challenge is to find a, b, and c. How we will find a, b, and c? Well, to do it, I will write common denominator is x squared multiplied by x plus 1. So I will put the same denominator in every term. So I have to produce a divided by x. So a divided by x is being produced if I multiply a by x plus 1. X plus 1 will cancel with x plus 1. The x will cancel with the square, and I will have a divided by x. How I will obtain v divided by x squared? The common denominator will be x squared plus x plus 1. So it should be b multiplied by x plus 1, because x plus 1 will cancel with x plus 1, and I will obtain v divided by x squared. Now I have to obtain c divided by x plus 1. So how I will obtain c divided by x plus 1 is the common denominator is x squared plus x plus 1. So I multiply c multiplied by x squared. The x squared will cancel and will produce the term c divided by x plus 1, c divided by x plus 1. Now I have two equations, the right and the left equation would have the same denominator, so the numerator have to be equal to the numerator. So 4x squared minus 2x plus 1 should be ax plus x plus 1 plus v multiplied by x plus 1 plus c divided by x squared, c divided by x squared. So using points, clever points like x equals 0. X equals 0 will produce a 0 here. So x equals 0 will produce a 0 here. So I can find v. X equal minus 1 will cancel the v, will cancel here, and I can obtain the c. And x equal 1 will make the a equal 3, and the problem is solved. Now, instead of solving this integral, I will solve this integral with a equal 3. So the integral that I will solve, it will be 3 divided by x plus v. V is minus 1. Minus 1 divided by x squared plus c. C is 1 plus 1 divided by x plus 1. And now this integral, the integral of minus x squared is right away. The integral of 3 divided by x is a natural log. And the integral of 1 divided by x plus 1 is a natural log of x plus 1. So the result is here, and this is the solution. Okay, let's go to the next problem. Next problem is evaluate the integral x squared minus 1. The numerator have a degree smaller than the denominator, so we can use partial fraction. So what is the partial fraction? The denominator is x cubed plus x, or x divided by x squared plus 1. Now there is a difference here. To use partial fraction in this case, we can use, this is a linear, this is linear, but this one, they don't have any root. X squared plus 1, they have imaginary roots, because x squared plus 1 equals 0. The root at x equal minus I, complex number, and x equal plus I and minus I. So when this find the decomposition for partial fraction that you will do is a divided by the linear term, and the other term, the quadratic term, we can say is Vx plus c divided by x squared plus 1. So this integral is being solved by solving this integral in the right side. And this integral is easier to solve than this one. Now the solution is here. We produce the same common denominator, find the same common denominator, and you solve it. Okay, this is the solution. Let me show you, and this is the solution. You take, you calculate A, B, and C, and the problem is solved. Next problem is more of the same. It's just to practice how to make partial fractions. Now we have the numerator. The numerator have a degree smaller than the denominator, much more smaller. Now we see this is a linear term, so it will appear a divided by x and v divided by x squared. Okay, this is a linear term, but it's repeated 3 times. So it will be c divided by x minus 2, d divided by x minus 2 squared, and e divided by x minus 2 cubed. When the linear term is repeated three times cubed, you need to add 3 terms like this one. So I repeat, the x squared is x repeated 2 times, so it will be a divided by x plus v divided by x squared. The x minus 2 have a root. The root is x equal to 2 minus 2 is 0. The x minus 2 have a root and is repeated 3 times. So it would be c divided by x minus 2, d divided by x minus 2 squared, e divided by x minus 2 cubed. And the last term, that is a quadratic term, is a square but have no roots. X squared plus 9 equals 0 have no roots. So you will say this is repeated 2 times, so it will be fx plus g, a polynomial that is divided by x squared plus 9, plus another polynomial divided by x squared plus 9 squared. So the difference is that when there is linear terms that have roots, like x minus 2 or x, the root is 0, when x equals 0 is 0, you use d divided by x minus a divided by x, v divided by x squared, but when they don't have roots like this, they are imaginary. The polynomial that you use in the numerator is fx plus g divided by x squared plus 9 plus ax plus k divided by x squared plus 9 squared. And this is a big job to find A, B, C, D, E, F, G, H, K. I will not ask you to do it, but this is the partial fraction decomposition for this integral. Let's go to the next problem. Use property of logarithms to verify that the natural log of x minus 3 minus the natural log of x minus 2 is minus the natural. You know how to do this problem for sure. Natural log of a minus natural log of b is natural log of a divided by b. So, and the natural log of a divided by b is minus the natural log of b divided by a. And this is the result here that you will find. To the next problem. Evaluate the integral 2x cubed minus 4x minus a. So what we have to do is the partial fraction decomposition. I see an a, x, so a divided by x. I see x minus 1, there is no square, so I will put v divided by x minus 1. I see x squared plus 4, it's not raised to the, it's not a square, it's just x squared plus 4. I will put cx plus d divided by x squared plus 4, because x squared plus 4 have no roots, have imaginary roots. So it will be cx plus d. Whatever it follows is just the algebra. You know how to do it. We already practice. It could be tedious, but you already practice. So instead of finding the integral of this function, you will find the integral of all these 3 terms. So you decompose the function into 3 a smaller function whose integral is more easy to find. Let's do the problem. Evaluate the integral of 4x squared plus x plus 3. So this, because they have the same degree of the polynomial, what you need is long division. So if you do long division, this will be 2 plus 5 minus x divided by 2x squared plus x minus 1. And now you make the integral, instead of making the integral of this function, you make the integral of this function, and the integral will be like this. And last problem, I hope, find the area of the region bounded by the graph y equal s. So to find the area, you need to make an integral from y equals 0, x equals 0, and x equal to make the integral of this function, you need to use partial fraction. And to use partial fraction, you need to decompose the denominator into x plus 3 plus x plus 4, and use partial fraction means to put this equal a divided by x plus 3 plus b divided by x plus 4. Now you find a, you find b, and you find the two integrals that involve. So you reduce the problem of finding this integral to find this integral. And the last, this problem I will explain in class, is the logistic equation. The logistic equation is the equation that say that ddy ddt is k by y multiplied by 1 minus y divided by L. And the logistic equation can be solved by separation of variable, but also can be solved by using partial fractions. Because I'm a little bit late, I will do this problem in another time. If you want, you can see what I have done here to solve the differential equations. So y of t, the differential equation, can be written like 1 divided by 1 plus v e minus kt. This is the solution to the logistic equation. Because there is an L here, this is the L will appear here. And this is the solution. Okay, what I have proved here, what I have done here, that I will slowly pass, is to find the solution, to find that this is the solution, this one is the solution. So I'm not going to explain because it's too late. So I make separation of variables, I integrate both sides. I do partial fraction here, a divided by y, v divided by L minus y. I find a and v is 1 divided by L. I integrate both sides of the equation, and finally I manipulate the equation to find y of t like L plus 1, and this is the result. You see it carefully and you will find this solution. And we will talk about the logistic equation at class. Okay, that's all.